Initially it started out as I just wanted a bike that was fast. It just needed to kill anything on the road. We've built a lot of really fancy, really nice bikes. So when we started hinting at the turbo idea, a lot of people sort of laughed it off and were like, okay, yeah, no, we see it, that's funny and whatever, but really, what are you gonna do? Like, nobody quite understood that we were genuinely serious about doing this turbo build. A lot of people are a little upset by it. Like, I think they were expecting something really fancy and like a clean line, classic looking Vespa. But we wanted to do something that stood out. We wanted to do something that was completely different. And we really like the metaphors that are drawn from turbo. You know, turbo, the whole storyline of that snail goes that it was a snail that was a petrol head and he wanted to be fast. And obviously he isn't. By design, inherently a snail isn't a fast thing. And when he got sucked in and injected with NOS and all sorts of stuff and how the story goes, he turns into this really fast snail. And that works so well with the Vespa because Vespas aren't fast. They're not intended to be. But when you're standing at a light and you're wheeling past M3s and things like that, that's what we wanted to build. And the shape works well, it looks the same. So visually it works, but metaphorically it works as well. So I'm actually quite blown away that nobody else has tried it yet. The biggest challenge was to try and get the motor into the right place. It's a completely custom designed motor by a company called BFA, built in Germany in conjunction with SIP. So what they did was they took the basic layout of a Vespa motor, they kept the mounting points the same, and they just improved upon everything from front to back in the design. So it's all still Vespa design, it's just morphed into something that can handle the power. I mean, we're talking standard ones are making 40, 45 horsepower on the wheel. The fastest ones are making 70, 75 horsepower on the wheel. So they used similar geometry on the gearbox section and the same mechanism, the same design. They just improved upon a lot of stuff. So they made thicker bearings, they used thicker walls on the casings, they cast thicker. But one of the big places where they changed is they needed to fit that massive piston in. So they needed to widen the section where the piston mounts on. So that whole part of the casing is, I think it's an extra 30 mil wider. When I started putting the casings together and we started assembling everything, I started finding a lot of imperfections in the CNC milling where they probably would have left it for strength-wise or for low down power. But when you want high power and you want things to be revving up nice and clean, there needs to be no resistance. So we de-restricted everything, smoothed everything out. And once you've got the motor built, then you need to understand what it is. Because every time you build a motor and it's something that you've never done, you have no idea how it's going to perform. Basically, that was when I tested it. I knew with the rough power figures and things and where I was going that the wheelbase would be too short. So the bike was going to just wheelie all the time. I also knew that I wanted to run bigger wheels on it. So we wanted to run 12s. And to fit a 12 on is fine, but it offsets the wheel further to the left. So along with moving the motor back, I also needed to shift the motor over to the side so that I could compensate and get the wheel back to the center of the bike. So I built custom mounts onto the frame that I had. And then along with that, designed a strengthening bead that went up through the frame so that it had a bit more rigidity. So we moved the motor over and then we decided we were going to get the fattest side cowl so that we could try and clear the motor, which was coincidentally off of a SS180. Now, clearing the motor in a stock setup when the motor's in its original location is already a problem with that engine. I started fitting it on, realized that there was no way it was going to clear, and started modifying and cutting out and widening the side panel to fit. I also knew that I wanted cold air going into the carb because the carb sits all the way at the back and it generates a lot of heat in there. So I put the scoop on the side and we started building all of that, all out of necessity. It was all sort of form following function. Put the side panel together, put it on the bike, and we stood back, looked at it, and I think I pointed it out to my dad. I was like, hey, that looks like turbo. So the biggest problem that we faced the first time around was that with the motor moved further back and having a bigger wheel on, it was not catching the back end of the bike. So we had to cut out the whole back side of the frame, which immediately put us at a problem, because that's where the strength comes from. You know, the shock mounts up to the top over there, so you remove that whole sheet metal piece and all of it gets flimsy. So I built a tube frame section at the back, moved it back by an extra 100 mil. And I had a piece of rolled tube that I was going to use for a different project. And when I placed it on there, the shape just kind of flowed. And I was like, hang on, this is really working out nicely. I like to build part by part and see how it comes together, and then edit to sort of make something as I go, the vision changes. Once we decided we needed a wheelie bar, that's when more challenges came, because the wheelie bar works off of 3 points. You've got the 2 points at the back, and then you've got a center point at the top where all of the stress goes to. And because we knew we needed it adjustable, because when you're on the track or when you're on the road, you need it at different heights, I needed it to swivel at the back. So with it swiveling at the back and going up to a center point in the middle, the left-hand side was strong because it had a solid piece of sheet all the way down, but the right-hand side had this big engine in the way, so there was no way to brace it. So we started seeing that the back side of it would move from this way. So hence the cross bracing of the tubes in the back. And then on the left-hand side, underneath the side panel, is a second cubby hole, if you will. And that cubby hole is made out of 3mm solid plate at the bottom, with the idea being that we sort of made a single-sided swing arm. So all of the strength can get transferred into that left-hand side. So that when there's force on the back end, that flimsy back end, it can get put across through to that back side around the wheel and then go back through to the main strength of the frame. So there was a lot of designing and a lot of engineering and going backwards and forwards trying to work out how the hell we were going to make that work. We ideally wanted to showcase what the shop could do. Initially it started out as I just wanted a bike that was fast. Then it turned into a drag bike with the wheelie bar and everything. We were like, okay, wait, we'll actually build a drag bike. And then we were like, but if you build a drag bike, you can't use it. You can't take it to the shows, you can't take it on rides and everything. So it needed to do everything. And it's also showcasing what we can do as a shop and what parts can come in. A lot of what I do is I build to a vision that I have and something that I think is really nice. And then it stands at the shop, and then people come in and they can see the parts in action and how they work with other parts. And a lot of the time it sells them on it, answers questions that they have, because they can see it on the bike. So it's more of a demonstrating bike than anything, so that people can see what stuff looks like. The next thing that we're busy with at the moment is paint. So paint, everything is at Ryan at Custom Creations for the meantime. He's busy painting everything out and laying everything down, and that will probably be where I'll see you next.